Hello, good afternoon to those in Brisbane and good day to those somewhere else or still jet lag. Just to confirm, people can hear me? See.
Yep, we can hear you.
Great. Thank you, Stephen. Welcome everybody to the meeting of the Rasprg Research Group. We have an interesting agenda. I hope everybody is looking forward to it. So let's move on with it. Can you move to the next slide, please? Well, as usual, the note reminder of all the Ietf considerations to be taken into account with regards to this meeting and its streaming. Next slide. Just a very brief mention. Remember that Rasprg is about understanding the standardization process via evidence-based reproducible work. The intended outputs are joint reports, papers, tools, data, and open source software, and it is not the intention of the research group to produce hierarchical comparisons between standard development organizations or directly influence Ietf operations. The chairs are Niels and myself. Niels will be stepping down, and Stephen is the delegate today, as both chairs are on remote. And of course, more information as usually is available in the charter. Next slide. Everybody is welcome to join the list and share data, requests, ideas, and papers, and please do so by using the link above. House rules, simple, please scan the QR code using the Meet Echo for the question and answer. And the speakers really appreciate it if you can leave time for question and answers, though I think that the agenda is not too tight, so that should be fine. And please get ready during the previous question and answers for your presentation. Can I also ask for a volunteer for note taking? Any volunteers?
There's no volunteers. Oh, there is. There's someone in the chat that's going to take notes. So thank you.
Thank you very much. Right, so moving on to the agenda. And apologies for the background noise, that's my dog. So we have finished the welcome, and please know that we have had a last-minute request for change in the agenda. Nick is going to be talking first about large language models and RFC GPT, which he was going to do at 15:50, but it overlaps with a side meeting on LLMs and networks. So please be aware of that. So Nick, if you can get ready with your presentation, the room is yours.
Okay, thank you. Thanks to the chairs for inviting me. So today I'm going to talk about a small project that I did over a few months ago in an effort to be more efficient in understanding our humongous archive of documents in the RFC series and making sense of them. Next slide, please. So this is an overview of the talk. This is going to be at a relatively high level. I'm not going to be going too deep into the technical details. The point of this talk is to give the audience an overview of how to get to something functional from just an idea, or at least the path that I took for RFC GPT. So from top to bottom here, we'll do a bit of a background on LLMs, how they're trained, how typical models are used or have been used in the last year or so in a lot of products. It sort of exploded in popularity, this model of being able to use machine learning to do human text. And so from there, I'll talk about one particular platform that was built to make it easy to build your own tool that can help answer questions and interact with customers in a textual way. I'll talk about RFC GPT, what went well, what was difficult about it, as well as future directions and next steps. Next slide, please. So if folks don't know yet, this has been in the news almost every day for the last year and a half since some high-profile announcements. But what is a large language model? Well, basically, it's an algorithm that takes text in and spits text out. It says artificial intelligence. It's sort of it's become a very broad term, but this is an algorithm that's designed to understand and generate text and interact with humans in a human natural way. And there are a lot of different machine learning models, including very popularly generative pre-trained models, GPT, which is based on some work for transformers, which was published within the last decade or so and has really grown. Next slide, please. Okay, so LLMs in action, how are these being used? How are people using them? Well, smart assistants, a lot of folks have deployed LLMs as chatbots. You've probably interacted with them, customer service agents, things like this, sort of replacing the rote conversations that you would have with someone on a website to support. That's one example. LLMs are great at text classification, taking text document and describing in words what's in it, what sort of aspects can be extracted from this text. It's also good at text generation. This is the heart of what has been really exciting for folks lately as these tools have become more and more sophisticated and more advanced. And the last one here is expert systems, and that's kind of a lead-in to what RFC GPT is intended to be. It's a system that is meant to act as an expert to give advice to folks who are less than expert on a particular tool. The underlying tech involves training data, which is just a very, very large set of text. And this text is processed, tokenized, which is effectively splitting up the words and subwords into smaller chunks. Vectorization, which is converting text into numbers, putting it into a large matrix. And there's a number of algorithms I won't really get into. This is, there are 10,000 experts in the world on this, and I am not one of them. But effectively, there's a lot of large natural language processing tools that take this training data and turn it into a predictive tool. So there's different techniques like taking your series of tokens and say removing one and teaching the neural network to predict what that token will be. An LLM is effectively an autocomplete with a ton of ability to go beyond just one word and a lot of context that goes into it. And so one of the interesting things about transformers, which has led to these things becoming shockingly much more effective in the last few years, is the fact that in the transformer model, to make your model, or with transformers, to make your model better or more efficient, you just have to throw in more data. And it's been remarkable for just getting better with more data put into it. So with training data, you get what's called a model. It's basically a large file of vectors. And a lot of folks have been doing this. There are models that have been trained out there on public data, private data, other things. There are private models. There are open source models available online. There's tons of tools to compare these and look at efficiency. And then there's platforms that are built on top of these, such as the Claude or ChatGPT, or there's a ton of other ones, Bard, for example, that essentially provide a user interface, which is oftentimes a chat interface, although it can be an API, and there can be additional filtering layers before an answer is returned to you, bias filters and things like this. But there's models and there's platforms. So you can run these models with appropriate backend servers, or you can use a platform. And these models themselves can be updated in various ways, or they don't have to be used as is. They're not set in stone. There's tools like RAGs, Retrieval Augmented Generation, which is effectively a way to take a model and put more data into it from something that I'll get into this a little bit later. We'll do the next slide and I'll kind of describe this. So with a retrieval augmented generation, this is one way to modify a model. There's also something called fine tuning, which I won't go into. But the API for a large language model is what's called a context window. It's a bunch of tokens that get sent in. And so if you're interacting with a chat model and you type a couple words in, it can go to the model. That's sort of a small amount of data to extrapolate what the response would be. With RAGs, you can take another set of data, tokenize it, vectorize it, put it in a database like Pinecone or something like this, and use it to basically augment what the query is to the LLM model. So you might say, tell me a story in the style of whoever, and then it can go to this other database, get additional context, and send that into the model. And this is meant to help inform the responses and make them more custom to whatever information you're adding to what is a pre-trained model. Next slide, please. So what does this talk about? What is RFC-GPT? Why did I do this? Well, there are a couple non-goals. Non-goals include building a collaborative platform for writing RFCs, building a tool for writing text for RFCs. This is definitely not the objective. The objective was to be able to interact with the RFC series in a different mode. And this mode is conversational and question-based. I find, reading a 50-page RFC document can be pretty dry, and oftentimes there are just particular questions that you want to ask it. And so the hope was that this expert service would be able to interact with you in a human relatable way and answer questions. So this is the goal. The interaction model, as I mentioned, hopefully it's an intuitive interface. Chat is one that's been popularly used, but there's definitely many other ways to interact with LLMs. But yeah, you can get explanations and summaries of RFC content. That's the point. So with this, there were some requirements, some things that it has to do, and it has to be able to have at least enough information in the model to be able to interact with its users in a way that sounds like a person. It doesn't sound like a machine. It doesn't have to pass the Turing test, but it needs to be able to write sentences and be able to glean context from different places and make relations and have sort of the base level of what we currently now expect from text-based AIs. So this is sort of the important part for the interaction, but it also needs to have the domain-specific data. In particular, the RFC series, it needs to know it. If there's like a really large base model, as I mentioned, there's ways to incorporate new data, or you could train your own entire new model. But the important part here is that the entire RFC series is internalized and known. Next slide, please. So I could have built this from scratch. That might have taken longer, and it might have been better long-term, and it may be something we can do. But OpenAI in November launched a feature called MyGPT, which allows the creation of custom versions of ChatGPT with specific use cases in mind. The underlying engine is GPT-4, which is the current OpenAI model. Next slide, please. One of many that they support, but most popular for folks who are using ChatGPT+. So there are 3 available features. There are a couple other features to this MyGPT tool. There's the instructions section, there's the knowledge section, and there's the code interpreter tool. On top of this, there are other tools like web search, which you can enable as well. But from the instructions is effectively a text window that lets you prime the context if someone were interacting with ChatGPT, this would be similar to them typing in whatever this instructions are as a prompt as the first step for interacting. So this can be things like, how do you know who the author is? What do you do if some failure happens internally and you have to search the web to download the RFC and all these sort of things. It's a lot of additional clues to ChatGPT to do the right thing. For the knowledge section, this is a RAG, or it's a RAG-like feature. It allows you to upload a lot of files, and it will tokenize and vectorize them and incorporate them as a first step for a RAG. So there's some limitations to this. It's only UTF-8 text. You can only use 20 files and 2 million tokens per file, 50 megabytes. But this is a drag and drop solution to creating one of these rather than actually going through and creating a database. The last piece here is code interpreter, which is a pretty nice feature, especially for code. But you can upload a zip file or .c files or Python files or whatever, and it will be able to execute Python code to analyze this data. So this is also really interesting for things like math problems and data analysis, things that are less relevant to this project. Next slide, please. So making the data fit. This was it's a beta product. Well, it's a GM product, but it's a new product. There were some issues. So in the instructions, there's a missing S there. There is a bias in the underlying model that's very, very hard to override with instructions. ChatGPT is going to ChatGPT, no matter how many initial tokens you send it. There are things you could do to put additional instructions in, but it will make things up, unfortunately, which is not ideal for an expert, although it does sort of reflect what real experts do in times. Okay, in the knowledge section, this was even more tricky. Well, the RFC archive, just downloading the RFC archive in a big zip file. A lot of the early RFCs are not conforming fully to UTF-8. There's a lot of special characters in there. ChatGPT will fail on these without telling you. And so you have to do some text transformations, and all these sort of things will actually change your tokens. So like an E with an accent will either split up the word or become something that's not necessarily relevant to just to match like other tokens that don't have an accent or are similar words or are presented in different ways. So this was tricky. Had to do a lot of manual processing on the RFCs to get them in here. And also the 50 megabyte files, that didn't really work. The upload failed. Tried splitting it into groups of 100, which is approximately 5 megabytes. And with that limitation, you don't get the entire RFC series, which is approaching 10K. Right, and the overall file, you can kind of approximate this from here. We're talking 5 gigabytes or so for the entire thing. So this was also tricky. It did originally work at first, and so the workaround that I did was to basically zip archive the entire RFC series and rely on the code interpreter to load individual files into context. This is a hack. It's definitely a hack, and it's a hack for which ChatGPT later disabled this feature after deployment. So it did break this. Next slide, please. So we did a soft launch, just launched this on Twitter or whatnot. You can go to Cryptography Consulting RFC GPT, or if you're a ChatGPT Plus customer, search the RFC store for RFC GPT. And there's been some pretty good feedback, about 400 conversations. Lots of issues, in particular with the code interpreter zip files, as well as uploading these 20 files and saving it. It is currently in a state in which ChatGPT will not accept my current set of uploaded files. It's in a draft state, and well, they use a GPT as their support, and it is no help. But in any case, we launched it. And it had a bunch of uses. Next slide, please. Yeah, so the early results, it was useful for me on a lot of different things, but if you're building a tool for yourself, that's fine. It's better if it's useful for other folks. Had some feedback from folks who were working on mod security, which is a WAF tool, trying to analyze some RFCs, and they actually found bugs in their code by interrogating some of these RFCs and corrected the behavior. So this is a positive result. ChatGPT is also able to understand different languages pretty easily. So this is somebody on Twitter tried to do a query about SRTP, and I didn't translate that, but effectively, this is what the output looks like. It'll be a set of answers, and these answers are meant to be helpful. And if you closely go through these, there may be one or two issues with accuracy, but generally, it's a good way to point folks in the right direction. And if you get an answer you don't like or something's not specific, you can dig in more, and it'll typically become more accurate if you ask the right questions. Next slide, please. Okay, so success, not yet. The limitations of OpenAI's platform were basically not catastrophic, but they did limit the ability for this tool to be effective and useful. So next slide, please. So future directions, there's a lot of ways you can go here. Using the OpenAI platform, you can build an external RAG. You can plug up APIs inside of ChatGPT and have it call out to external services to do this. So there are a lot of platforms that allow you to take all this extra data. Eventually, it could be interesting to expand this training data to include the mailing list archive, which is where a lot of conversations happen and a lot of important context happens for these RFCs. Definitely way too much information for the current platform. The third part here is important, which is open source models. As of now, the tool is fully closed source, relying on a closed source model, and you actually have to be a paid customer of ChatGPT to use it. This is no good, but it was fine for a first draft to test this out. And the last part here is quality measurement. There's no tools to measure and really give a quality score for how well this tool is doing as an expert on the RFC series. So there's a lot of work there to do. And so I would say a mixed bag, but it was useful, at least for me, to use a new model of interacting with the RFC series and find some interesting things out about how these platforms work and how simple and low effort it is to build tools on top of existing platforms to be able to build something like an expert service. So the point here isn't that everyone should use this to understand Ietf RFCs, but that this is an additional tool that can help you reason about the text that's in it, ask questions, interrogate, and oftentimes you don't know where your answer is, and something like this can help point you to the right RFCs. And next slide, please. And that's basically it. So at this point, I'm looking forward to any feedback about RFC GPT if you've seen it, about the directions, and open to questions right now.
Hi, thank you very much, Nick. I think we have quite a few questions. If people can make the questions relatively succinctly, that would be great, as we might run out of time otherwise. Thank you.
Hi, I'm Alex from Siemens. I have a suggestion to include in the future direction. That is the use of this thing for generating test cases. So I implement a tool that quantifies or measures compliance with a certain RFC, and I use the plain ChatGPT to have an initial draft of writing use cases based on must not, should, and so on. I think it's a logical next step, and I would be happy if it were included in your roadmap.
Okay, thank you. I think if I were to conceptualize this, I'd probably separate the generative versus the analysis side, but under the hood, I think it's definitely a good direction to look into. Generating test cases are always great. next.
Thanks. Hi, Jay Daly, Ietf Executive Director. We were talking about this earlier today, the rest of the tool team and me. Our thoughts were to actually create a database so that we would take the RFCs and create the vector database and make that as an open resource for people to use based on the RFCs underneath it. Potentially also then to have, a series of custom prompts on top of it that enables people to query that in some sort of way. If we did create that open vector database, would that be of use to you at all?
Yeah, that would be great, because you could just plug this in as the RAG for this rather than the janky OpenAI user interface. So any way to take the RFC series and present it in a database form that could be useful for these styles of tools and with the APIs that these styles of tools expect would be great, and it would be super useful for this and generally for the Ietf.
Okay, thanks. And on your last slide, you mentioned fine tuning. Do you have a series of, do you have data of, questions and replies that you can use for fine tuning at all?
Not yet. No, and I think with regard to fine tuning, it's not necessarily about questions and answers as much as just training new data into the model and updating it with new data without having to retrain the entire model, which can be extremely expensive.
Right. Okay, thanks.
Yep.
Is it my turn yet?
Yeah, really interesting. I guess in terms of like the audience for this, I wonder if you have thoughts about kind of who this is kind of best for, or equally who shouldn't be kind of using this. Thinking, I guess, about communities both within the IETF or like external communities kind of outside of the IETF and some of the issues around like hallucination or kind of other things. And then second kind of shorter question, just around extending this. You mentioned mailing lists, but did you have thoughts about like the drafts that are currently in progress as opposed to just kind of published RFCs?
Oh yeah, for the second question, basically any artifact generated by the IETF could be incorporated. There is a lot of data, so thinking about how to do that right is difficult. What was the first question? It was about?
Just about kind of audiences for this tool and people who maybe shouldn't or should be using it.
Yeah. This is a dangerous tool in the wrong hands as of today, and if you are not at all aware of how the IETF works. So I think the audience for this is folks who have a baseline understanding of the IETF and RFCs, but want to be more efficient at finding answers to questions that they may have about the RFC series.
Jérôme François, thank you for the presentation, and really support the idea. Just a question, because you say so you use RAG, and at some point in models they have already been trained with public data sources such as RFCs, and I was wondering, in your next step, you mentioned that you want to measure quality, even if it's not defined how. If you will try to look at what will be the difference with the RAG approach, without the RAG approach, but maybe instruct, for example, GPT models to be contextualized with the already sources of information included.
Yeah, and GPT-4 has also incorporated a good chunk of the RFC series, but playing with it plain, you really have to use the web tool or the web enablement for it to actually download things, especially with older RFCs. So yeah, I think there's lots you can do.
Sorry, I was next, but I think my question got asked by Marek. I was also wondering whether you could extend this to internet drafts, and I was thinking of people that are preparing for IETF and to do sort of engagement in the space. Do you think that would be sort of useful for people doing prep work, I guess?
Yeah, I mean, one use case that immediately comes to mind is as a chair of IETF group is to get a sense of what is the timeline of the drafts and what changes have happened and why through the conversations in the mailing list, and it could be useful for accountability for chairs as well.
Great, thank you very much. I'm afraid I have closed the queue because we are already running over time. I think this is super interesting. I would be super curious to have a debate about what will be the role of these tools in, let's say, 5 years when they are not in, these tools are not in their infancy, hallucinations are not such a big problem, and the whole process is more streamlined. Thank you very much, Nick, and we can move on to the next talk. So thank you again. So the next talk is by Carolina Cairo from the DNS Research Federation, and she's going to be talking about the Internet Standard Trackers. Carolina, the room is yours.
Thank you, Ignacio, and good afternoon, everyone. So yeah, my name is Carolina. I'm with the DNS Research Federation. We're a UK-based non-for-profit organization, and our mission is to make sense of the internet through data and research. Yeah, next slide, please. All right, so this presentation is actually a follow-up from a presentation I did at Ietf 118, where I introduced the Internet Standards Observatory, which is an initiative we're running at the DNSRF, and a tool that we have launched as part of the Standards Observatory called the Standards Tracker, which until the last IETF meeting, we were using solely for tracking ITU standards. Today, I will be doing a brief recap for new people in the room about the Internet Standards Observatory, what it is about. I will also be speaking about our standards tracker and how we have expanded coverage to IETF. And then I'll be also addressing how we took in some of the feedback that we received at the Prague event. So next slide, please. All right, so the Internet Standards Observatory, what is it? So this is an initiative funded by the Internet Society Foundation and the RIPE Community Fund. And essentially the goal of the Internet Standards Observatory is to help identify and track standards proposals that could potentially challenge interoperability in the internet. And specifically, our Standards Observatory hones in on standards proposals that could potentially transform how we do addressing, naming, networking, and routing on the internet in ways that could fragment the internet essentially. Next slide, please. So why tracking internet standards? So the first thing we always like to say when we present this project is that we find that SEOs, especially IETF, are obviously an opportunity to make the internet better and to ensure that interoperability that we are concerned about. And really sort of the purpose or what we're hoping to accomplish, I guess, by doing the standards tracking is to ensure that we are discussing internet standards in the right fora. And whenever internet standards are not being discussed in the right fora, that the community is aware of that. And we're also hoping to encourage participation with standards proposals that could potentially shape the internet of the future and really sort of encourage thorough conversations about how we want the internet to evolve. And lastly, we're hoping that our internet standards tracking can help lower barriers to engagement in standards, essentially by sort of facilitating analysis on standards proposals and helping standards participants sort of figure out which proposals they may want to sort of prioritize in terms of tracking or engagement. Next slide, please. All right, so the standards tracker, next slide. So what is the standards tracker? So the standards tracker really is the heart, the bread and butter of the Internet Standards Observatory. And it's essentially a tool to automate the identification of standards proposals by topics of interest. And as I mentioned before, our areas of focus are, again, proposals related to naming, addressing, routing, and networking on the internet. So what we do is we input standards proposals into the DAP, the Data Analytics platform of the DNS Research Federation. We essentially scan for specific sets of words in those standards proposals that are related to our topics of interest. And then what we do is we generate a score essentially based on how many or how frequently those words and phrases appear in the documents. And this score enables prioritization of standards proposals. So essentially, we sort of organize the standards proposals we analyze into 3 buckets by order of sort of priority, from sort of the ones requiring sort of more immediate or more direct engagement, if you will, to proposals that we think the community should monitor, and proposals that we think the community should track. In terms of our focus, this is also an important sort of caveat to sort of highlight to the group. Our focus is on standards proposals that are currently under development, so we don't track approved standards and sort of their deployment or adoption. And the SEOs of focus are 3. We started off with ITU-T. We've expanded the tracker to Ietf. And we're going to be launching shortly the tracker for ETSI, which is the European Telecommunications Standard Institute. Next slide, please. So this is what the tracker looks on the website of the Internet Standards Observatory. So I'm going to get started with the ITU tracker just to show you the updates since the last presentation. Next slide, please. So this is what the tracker looks like. So in the bubbles at the top, you can see the 3 study groups that we are tracking for ITU. These are study group 13 on future networks, study group 16 on multimedia, and study group 17 on security. And essentially what the tracker does is it shows you sort of a list of the standards proposals that are being discussed in a given group, sort of ranked, if you will, by how closely they match our topics of interest. Next slide, please. If you click on one of the, the standards proposals, you're presented with sort of more detailed information about the standard in question. So you essentially get to access things like the title of the proposal, the proponent, what the proposal is about, what's being proposed for standardization, and associated use cases that are sort of presented or discussed in the standard proposal. So here in this case, we're looking at a standard proposal on computing and network convergence that was presented at study group 13. Next slide, please. The tracker also enables you to do filtering. So say if you participated in the study group 13 meeting that took place right before IETF, you could select the March meeting and be basically presented with the standards that were discussed in that specific meeting. And then there's also other elements by which you can do filtering. For instance, if you were interested only on looking at new work items, you could select that and view that subset of standards proposals. Next slide, please. And here we have another example of how you can do filtering. So say you were interested in a specific use case. In this case, I selected augmented reality. Again, you can be presented with the standards proposals that focus on that specific use case. Next slide, please. All right, so onto the IETF tracker, which is our recently launched tracker. Sorry. Thank you, Stephen. So this is what the IETF tracker looks like. In the case of the IETF, our sort of organizing principles, so the bubbles at the top, are the IETF meetings. And here we did something interesting. Essentially, the way we were able to sort of compile this information was by scraping the meeting materials. And whenever we identify a phrase that starts draft dash, we know it's basically an internet draft that's been sort of included in the meeting materials. And that way we're able to populate the list that you see here on the screen. And very much like the ITU tracker, what we do here is we present a list of internet drafts that are being discussed at a given meeting, again, sort of ranked or sort of prioritized in order based on our areas of interest. Next slide, please. And again, like the ITU tracker, you can click on a specific standard proposal, and then you're presented with information for that specific proposal. Given that the data tracker gave us a lot of great organization or systematized information, if you will, about the different standards, we've organized it in 3 blocks. So basically, you can see where the standard is being discussed in the agenda, what the standard is about, and the standard status. So here, basically, we are looking at an independent draft that was presented at a routing area working group, and it was a proposal on BGP blockchain. Next, please. Next slide, please.
Caroline, a quick question. Is
Yes,
this,
of course.
is this live? Because I tried using it and it just shows blank for the IETF at least.
Oh, that's strange. No, it is live. Are you on
Okay.
our site?
Yes.
Okay, it
It
should
might,
work.
it might well be me. I'm just on. Okay, I'll try
Okay.
harder.
Yeah. Are you having the same issue? Oh dear. Okay. All right. That's something that we'll look into. It was working fine for me all week, so but we'll have a look. So I'll continue on with the presentation. So yeah, here I guess I wanted to show that just like in the ITU tracker, you can also filter by items of interest to you. So here again, I'm filtering by use cases. Say you wanted to look at proposals related to the metaverse, you can select that and see which proposals we're flagging there. Next slide, please. We also recognize that people that use the tracker may be interested in actually searching the tracker for topics of their own interest. So here, say you were interested in, RPKI, what you would do is you would select all the drafts and you would type your search term in the search box, and it would, provide you with the drafts that are being discussed at, in this case, IETF 119 on RPKI. In this case, we're getting, I guess, unsurprising results. It's sending you to the CIDR Ops group, obviously. But if there were internet drafts on RPKI being discussed in other spaces, perhaps that you wouldn't expect, this will help you, make sure you're not missing out on any relevant presentations that you're interested in tracking. Next slide, please. So I wanted to show you very briefly the backend of the standards tracker, just to sort of, emphasize how the methodology works. Next slide, please. So this is our data analytics platform, and essentially what we do is we upload the internet drafts, or the contributions in the case of ITU that we're interested in analyzing. Next slide, please. We have also curated a set of dictionaries that we use to do our scoring. Essentially, we have 3 dictionaries at the moment, one for what the standard is about, one for what's being proposed for standardization, and one for use cases. Next slide, please. And here we show you how we do the scoring configuration, which is really straightforward. We essentially assign different dictionaries different weights. And also there's sort of slightly different weights for how frequently words appear on the documents. And that's basically how we arrive to our scoring and how we do the sort of the ranking, if you will, on the tracker. Next slide, please. All right, so feedback from Prague. So we received a lot of questions, great questions actually, on our methodology. Basically, we had questions on the meaning of track, monitor, and engage, and also on the color coding that we were using up until the earlier version of the tracker. We've now gotten rid of that. We had questions about how to access our dictionaries and search terms. We heard suggestions to sort of include features that would allow to broaden the search terms. And we also had a comment, asking us to sort of understand or pay attention to the status of the standard, and whether if a standard was in a very sort of advanced stage, whether it made sense to have engagement with that standard proposal. So what we did in response to the feedback we received is we created a new section explaining our methodology, which is on the Internet Standards Observatory website. Our dictionaries are now open, and they're also visible through the filtering. Essentially, those sort of boxes that you can take on the left of the tracker are actually our dictionaries. And we also enable the search box for people to be able to do their search for their own terms. And we have added also the status of the proposal. Next slide, please. So next steps, so on the technical side, we still have quite a bit of work to do on improving the search box. We're currently looking at titles of proposals and words that, within the proposal that match words in our dictionaries. So we are intending to improve the search box so that it can actually search the entire text of the internet draft. We also are running other projects where we're doing AI-powered semantic analyses. And we are basically going to test the AI semantic analysis for the tracker. So we're not bound to be looking for specific terms or phrases, but we can rely on the AI. So this is something that we're going to test and possibly deploy. And we are also hoping to participate in future IETF hackathons, so our team can basically socialize with the IETF community some of the work that we've done. On the content side, very quickly, we're beginning to plan for expanding our topic coverage, essentially to focus on emerging technologies. So we want to more formally expand analysis to metaverse, quantum, network trust, and other areas. We're going to be expanding the study groups that we are studying within ITU and the ETSI tracker, which is forthcoming. And I had a couple of extra slides, but I think I've run out of time. I will let Ignacio tell me. If not, I'll run through this very quickly. Lastly, I guess I wanted to wrap up. Sorry?
If you can do it quickly, that would be great.
Okay, yeah, I'll take a minute. So the last couple of slides are essentially to highlight that as part of the Standards Observatory, we're also putting out there a series of resources for the community to really sort of make sense of trends and developments across different SDOs. So we recently launched our blog series. Here you can see our latest blog article on the DELEG BOF that took place yesterday. Next slide, please. And with the support from the Internet Society Foundation, we're also funding 7 wonderful research projects related to standardization processes across SDOs. Next slide, please, Stephen. And here I put on the screen a couple of the research projects that we are supporting, especially the ones where we are collaborating with researchers from the Rasprg community. So we're working with Ignacio, with Stephen, also Yag, who's I think in the audience somewhere. I think I see you back there, yes, and a couple of other folks. So these are resources we're also going to be putting out there. So yeah, you should be on the lookout for that. So that'd be all for me, and I'm happy to take comments and questions. Thank you.
Great, thank you very much. I think Jan is in the queue. We have time for a few quick questions.
Hi, thanks for the presentation. That was great. There's a lot of stuff that I was already looking into, and I'm happy to see that there's implementation. Would the information that you have be only available through the website of the tracker, or are you also planning to have an API?
Good question. We haven't planned for an API, but we could do that easily, yes. I will say in terms of sort of our work being open, that our code is open and available now GitHub repository, and I can actually maybe share that on the list, as are our dictionaries as well. So yeah, so that other people can sort of interact with the data and the software development that we've engaged in.
If I may do a very quick follow-up, are you thinking about publishing an RFC with that dictionary?
We weren't thinking of it, no, but we could maybe discuss that. And yeah, that can maybe be a conversation for us to follow up on. Thank you. Any other questions?
Great. Well, thank you very much. Well, I see that there is one last question. Yes,
yeah,
please go ahead.
Yeah, Jonathan, I see him coming up to the mic.
Sorry, I was having issues getting the thing to thing.
No worries.
Jonathan Hoyland, Cloudflare. How much of this work per time is manual? Because just like identifying the number of times someone has like misspelled a draft, or like the notes aren't quite perfect, or like people have done stupid things. Seems like it would be very hard to keep this accurate without loads of manual work.
Mm-hmm. Yeah. So I guess you're referring to the scraping that we do of the meeting materials.
Yeah.
This is actually a good question. We don't do any manual work. We scrape them, and what the system sort of picks up, it shows on the tracker, and what it didn't or what it missed, it just doesn't. And one of the suggestions we received in the Prague event was maybe working with the folks developing the data tracker, and working with them in sort of figuring out ways in which we can know whether a given draft is being discussed at a meeting, and sort of having a more stable way, essentially, of inferring that information straight off the data tracker. Right now, because that information doesn't exist, we sort of have to, we did this workaround, I guess, but it is indeed imperfect. Yeah.
And is there a way for people to like issue correct, like if I wanted to fix it, could I just go in like, oh yeah, this is linking to this draft? Or
yeah, I mean, right now we don't have a way for the community to sort of go into the system and do corrections. So I think contacting us via email would be the best. But this is a great point, and that's certainly an area for improvement. So thank you for highlighting that.
Thank you.
Thanks. All right.
Okay, thank you very much, Carolina.
Thank you, Ignacio. Thank you, Stephen.
Thank you for the great talk. And Priyanka? Yes, I can see you. I can see your deck coming up. So now Priyanka is going to be talking about computationally understanding the IETF consensus process. Priyanka, the room is yours.
Hello. Hello, I'm Priyanka, and I'll continue the conversation that we have been having from my previous presentations at the Yokohama IETF, where I presented my PhD work at the Rasprg, and the position paper in 2021 at the IAB AID workshop, where we wanted to study consensus processes at the IETF. We learned about tools like Ietf data, which collects data from data tracker, and also about Big Bang, which interfaces with Ietf data and W3C. So continuing from that conversation, I wanted to talk about understanding the consensus process computationally using tools like Ietf data, and then BERT topic, which extracts topics statistically from text, and Empath's pre-trained model, which provides insight into psycholinguistic processes from text. Now, I've conducted my experiments on V6 Ops and 6-man working group mailing lists. Next slide. So we know that the consensus process is slow, but different groups and topics have different ways in which the consensus builds. Now, by topics here, I mean statistical topics, like issues surrounding ICMP V6, for example, and not a particular thread on the mailing list or a particular IETF draft. We could analyze topics for a given draft or a particular IETF thread. It's just that I haven't done it for them in this experiment. My hypothesis here is that by creating a fingerprint, that is a temporal fingerprint of the way the group as a whole is represented by the mailing list, one could characterize that mailing list and understand the various ways in which consensus is ongoing in these groups and topics. And then by understanding the temporal psycholinguistic aspects, we have a fingerprint on how the group behaves and how it is different from other groups. This should in future help us study what makes consensus slow or fast in the IETF. Next slide. So after applying BERT topics, dynamic topic model on the email messages in the V6 Ops working group mailing list, we see that there are some topics that have been discussed for a long time and some which are only of interest for a relatively short time. On the y-axis is the amount of the topic being discussed. The x-axis is time, that is from the year 2008 to 2024. And each line graph represents a topic in the group. And the legend on the right is the set of top most frequent words in that topic globally over time. Whether we use threads or messages to generate the topics, the results are similar. The top graph is generated using the thread's first message, and the lower graph is with all of the messages. And each topic here over time, over the years, may have different specific top words but essentially the thought has continued over time. For example, around 2018, there was activity around a transition of IPv4, and around 2014, it was around IP6 tables, ICMP-v6 filters. So it's you can see visually that there is some severe event that has happened around 2011 that had an impact on the working group. Next slide, please. Doing the same for the related 6-man working group, we see that the topics until 2011 were sparse. There have been discussion around ICMP v4, v6, VPN. As you can see, even for a related working group, that is v6 and 6-man, which are related, the temporal topic activity here is different from the v6 ops working group, even for related topics. And there's some similarity of peak activity in some major events. Next slide. To reduce the noisiness of the graphs, I have selected a few representative topics to showcase which of these topics had activity over time to understand whether consensus was achieved slowly or fast in the same working group. We see that eBPF, point-to-point IPv6 table, is an ongoing topic still, whereas IP-to-IP, dual stack light, and loopback is no longer being discussed. Next slide. Afrinic was discussed for a very short time, and hop by hop is still being discussed. These results should be obvious to participants of the working groups, but this kind of computational analysis provides this insight to anyone else in a data-driven manner. Next slide, please. Now, by applying the empath model, the psycholinguistic model on the messages in the v6 ops mailing list, we have some interesting findings as well. Now, the original model, a pre-trained model, has 200 categories, and which can also be fine-tuned for specific data sets. However, I've used a small data set of categories that may be of interest to the Ietf consensus process. In v6 ops, even though in the early days around 2011, people may have felt a lot of negative emotion, there's some fighting and some hate, in general, the amount of anger, feelings of torment, ridicule, exasperation, irritability, timidity, and politeness have been low. And so have joy and cheerfulness been low. Now, but participants feel some need for negotiation, confusion, there's some confusion, there's some disappointment, there's some celebration, and there's some trust, which relates to a possibly healthy working group. Next slide, please. In the 6-man working group, we see similar behavior with some differences, such as there are some frequent disputes, frequent celebrations, frequent fights. So these temporal psycholinguistic time series contribute to the fingerprints of the working group and its evolution of its consensus process, as these group behavior contribute to the same. These working groups with a similar time series would be expected to computationally have similar consensus process. Next slide. Now, I did try to capture the psycholinguistic processes for specific selected topics in the working group, but the existing models has very low coverage for them. So this may require some extending of the model, the algorithms itself. And the set of time series from this early experiment, along with the code to generate them, are available at the GitHub link. And over time, I hope to improve these techniques and provide more meaningful results. Next. And with that, I would like to thank APNIC for the funding, and my employer, Docket AI, and IIESOC and INTC for their support. And now I'm open for questions. Thanks.
Great, thank you very much. We have 2 questions from Jonathan and Susan at the moment. So Jonathan first, please.
Hi, Jonathan Hoyland, Cloudflare. Do you consider author of the comment as one of the key factors? Because I think, at least my experiences in certain working groups, you can get one person saying no, and suddenly everyone's like, okay, let's not do it. Or one person's like, yeah.
Yes, definitely you can redo these experiments where you are doing it for a particular person who's the author versus somebody who's commenting, etc. But in this particular study, this early study, I'm just considering everybody to be the part of the group. So it's like, so I'm not distinguishing between who's the author and who's the commenter. But yes, that is definitely doable.
Because you'd think group dynamic would be a big factor in how you get consensus.
Yeah, and if you were there with Sebastian last time, I mean, he's also interested in seeing that there is something that's happening around V6 ops in IETF, which is endogenous in this mailing list, but there could be exogenous factors like outside factors, which are happening in some other mailing list, let's say, 3GPP or somewhere else, and that might be impacting us. So this is just a very early study.
This is really cool. Thank you.
Thank you.
And the next person in the queue is Susan.
Thank you for a very excellent presentation. Two questions. Did you consider the area of the working group? Ops is a very good area to get a broad thing. It would be fascinating to see you pick a working group in every area of the ITF. I think that would provide some very good feedback. Second, could you send me what the definition of consensus that you were using? You don't have to tell me now. I don't want to take everyone's time, but consensus, how did you define it? How did you look at it? That sort of thing actually impacts your studies your statistics are well laid out, but the definition of consensus.
I totally agree, Susan. Yes, this is very early. I'll reach out to you. Thank you for the comments.
Fantastic. Thank you very much, Priyanka. And the last talk of this session is from Geoff Houston on the wonders of making RFCs nowadays. So, Geoff, the room is yours.
Yeah. Hi, Geoff Houston. I'm really not sure why I'm here, but I did write, I did write a blog article at one point because I was trying to get a draft through the process of producing an RFC and got amazingly frustrated. It just strikes me as insane in some ways that there are all these review teams doing all this review, and yet there's a massive amount of errata coming out anyway. And you kind of wonder exactly where and how does quality come from? And it certainly doesn't appear to come from the massive amount of review process that happens in the final stages of an internet draft. It just seems like a whole lot of work with almost no benefit. Next slide. So I started sort of musing about this and looked through the data tracker document, and I had a few questions, exactly how long does it take to produce an RFC? And are we kind of bogging down in this process? Or have we got more streamlined and efficient? Or is it a case that the more we do this, the more every single RFC seems to be a surprise to the process? Oh my God, let's do this all from scratch again. And the other thing too, what's the success rate for drafts? How many drafts actually get published as an RFC at some point? So those are a few questions. And I just looked through the data tracker and kind of collated some stats. So next slide. Right now, currently in the current drafts repository, there are 21,185 internet drafts, which have basically unique STEM names. The average version count is now 6. And surprisingly, the amount of time we take to cook a draft is now 2 years and 4 months on average, which to my mind strikes me as astonishingly long. You want to jump up now, Susan? Because I don't really care. You want to leap up and make a comment? Make one, otherwise I'll plow on. I'll plow on.
I love hearing you talk.
Oh, God. This is not a deep talk, okay? It's just a talk of frustration. Next slide. So then I started to look again at the full data and, months. There is an outlier out there at 260 months. Truly, truly, truly. The average draft age, as I said, is, what did I say it was? 2 years and something. But if you look at that distribution, there's an awfully, awfully long tail, you know, and that count, as I recall rightly, you know, is in months. And there's a huge amount of drafts just sitting there as if aging them makes them better. It doesn't. It makes them less and less relevant as time goes on, is my view. And I don't understand why there's just so much stuff just sitting there gently rotting. Next slide. And of course, the classics.
Jeff,
I
I have a quick question. Do you filter out the drafts that are with the ISG? In this
No, it's in the current repository.
Right.
So
the
I don't care if the ISG is letting them age or something else is letting them age.
So
Someone's letting them age.
It's the long tail has a reason. So if you want to do this analysis and look at the Ietf process, I would encourage you to limit it to the time before ISG, because after ISG, there's individuals that have disagreements that go on for 260 months. Several ISGs have told them that, you know, it's not going to go forward until this gets fixed, and they disagree with that.
I'm not looking for reasons, Lars. I might. You might. I'm not. I'm just saying they're sitting there rotting. And these are the worst. And I really don't understand about Mr. Edwards and Telnet and his Exonix offstate. I can't find it anywhere else. And I honestly think that's a mistake. But, you know, on the other hand, draft Kunze ARC, which gets faithfully date updated every, whatever it is, 3 months or whatever. And he's been doing it now 37 times. Persistent. And I don't know, again, if that's it. Sorry? Oh, God, no. These are the old ones in the current drafts repository. They're the ones that are sitting there aging. These are the oldest things there. I'm not attributing blame to anyone. I'm observing what's in that directory. So, you know, nothing personal here. It's just what I see. Next slide. Now, this is kind of interesting because we do dates and there's an incoming draft rate. I had a data drop somewhere around, 2017. But you kind of see IETF meetings cause the draft per week to rise up to around 400. And so there's this background activity of submitting drafts throughout a year. And then there's kind of a cutoff, and then there's bang, stuff comes through IETF meetings, and it sort of goes about 4 times the running average. Next. And here's I blow up. I've forgotten which year, 2023, and just look at every week in 2023, and it's immediately obvious, the IETF meetings and cutoff weeks, that there's this sort of flurry of activity in the 2 weeks before an IETF meeting or before the cutoff point, draft. Post-meeting, not so much. So we think the meetings are a case for working groups to meet and sort of work through the draft rate and sort of produce a new version of the draft, not as much as the stuff before. Afterwards, it very quickly lapses within 2 weeks down to ho-hum, business as usual. Next. This is a longer one, drafts per month from the year 2000. And I'm trying to see the long-term rate here at a monthly level. I'm trying to get rid of the IETF meeting factors, which are the peaks, and looking at the longer term of, has the activity in the IETF grown or got lower? So since about 2009, steady at about 350 drafts per month, sort of. Next. But the OO submission rate is much lower, around about 50 to 80, 00 drafts per month outside of the meeting months, and that's been since 2003. Since 2003, the amount of incoming work items coming to the IETF as done by OO drafts has actually been steady for now 20 odd years. COVID period, small decline. But, what you actually notice from 2003 to 2009 is the amount of cutting and polishing, 01, 02, 03, 04, that's increased. And then that decreased again later on. But the basic incoming work pattern has been incredibly steady. Next. So let's move on to RFCs. and the success rate. So since 1989 in the repository, you have a comment?
Yeah, I was going to comment on the last slide.
Name?
Richard Barnes.
Oh, okay. Sorry, Richard. It's the mask, mate.
Yeah, no worries.
Previous slide, thanks. Yeah, backwards.
Yeah,
Thank you.
so I note that this decline in 2010 or so correlates roughly when GitHub started to be a thing that we started to use around Ietf. So I wonder if some of the change, the lack of revision you're detecting there may have just be revisions happening elsewhere.
I like that theory. Personally, I loathe GitHub with an intensity that is probably unrivaled. But nevertheless, I can see that other folks seem to love it. So, you know, love it or hate it, but nothing in between. So you're right. It could well be GitHub reduces the intensity of the revisions, because previously you kind of sneezed another revision. Could be right. Susan.
4 points. I just got to 4 and I lost all the things.
Yeah, right. Well, let's get rid of the 4.
You know, I
don't have the patience to go through 20.
So, number one, I did a 10% look at drafts in detail, blow by blow, sequence by sequence, which tells you I went deep dive instead of the sort of round statistics that you did. Meaning I tracked them and I tracked when they went through the ISG. You need to listen to Lars. ISG time matters. Number two, the publication time varies, which you probably are maybe getting to, but the publication time varies. And it varies for a variety of reasons. There's a lot of post-processing. You want me to keep going? You want me to
I was going to notice that Christian Wiedmer actually did an RFC on that exact same deep dive, which is at the back end of this side pack. So yes, there are a lot of reasons.
There are reasons.
I'm not giving you reasons.
No,
I'm giving you numbers.
Yes,
and
that's all. I have some of the same numbers. Yeah. The ISG process has some ebb and flow as well. You know, the lacking process has an ebb and flow. So I'm trying to say, while this is interesting, you're getting some false positives and some false negatives. I look forward to talking to in detail.
I think that yellow thing at the bottom is kind of important.
The yellow thing at the bottom is kind of important, but the thing that goes beyond it that you might want to consider is whether, and this goes back to some research done around 2007 by Simcoe. I think it matters whether the content that the previous speaker does. Apparently, it's really easy to do little revs, see SR routing, but it may not be as, the big humps are different, Jeff.
Right, but the incoming work rate was really where I was pointing.
Yeah, but the incoming work rate is varied based on whether it's a new big work or it's a whole bunch of little drafts that are iterated. Just a thought.
Okay. While we're having fun.
Yeah, well, might as well get in.
Yeah.
Alistair Woodman in. So I can't quite, as a description of what's happening, I think it's really useful. I still get the impression that you're there's a negative observation to this, that this is not good. Is that correct?
No. This all started because I was just pushing through one draft that seemed to be taking forever. And I had a negative impression of the treatment of my draft, as does everyone when it takes forever, purely personally. And then I started to look at the big numbers and I'm kind of going, well, these are the big numbers. I really don't have a criticism or not. It's just.
Oh, you think you're being fairly mistreated as opposed to unfairly mistreated?
Isn't everybody?
Yeah, okay.
Oh, okay, fine. We agree.
Okay, right, good. Okay. So, because I think that this is like it's supposed to be.
I don't know. I don't understand what supposed is. But we will see. I have some more data on RFCs.
So I'll just make the observation that it should be progressively harder to make modifications to that. The low-hanging fruit is all gone. So it should be more and more complicated because you've got to deal with the integrated sum of all that stuff that these guys have been recording and looking after, right? So it's got to be harder.
Hold that thought. Next. Because it's a good thought to hold. 39,719 drafts. RFCs in the same period, not so much. And the success rate, as far as I can see, in looking at the conversion rates, is 21%. We managed to get rid of the bit at the bottom, 1,130. We updated a few. The verified errata, I actually didn't take into account grammar. This is technically verified errata quite deliberately. So, you know, commas, the, and anything else, you know, that everyone slips up on, nah, that's not here. But the ones where there is a true, this is a problem and it needs to be recorded, is a lot lower. So 21% conversion rate. Next.
Sorry, on the conversion rate, you're taking into account individual drafts that get adopted as working group drafts as parts of the conversion and not just drafts that disappear, right?
It starts, it gets adopted by a working group, goes through the IESG, name changes a few times, then ultimately out pops.
You're tracking the name changes.
And yes, because someone did that, and it could have even been there's a data tracker record. There is a record out there that says this became that, became this, became an RFC.
It's very incomplete in the data tracker.
It's a wonderful thing. 21%. Next. So this is the publication rate from the RFC editor from the date. So you can, there are some ones out there from the year dot. Things started to go, you know, with 1990 with the NSFNet, and off we go. Alistair, you can start to see that tail off because next. Now I have missing data, which is a pain in the butt, but this is from the first draft of the first kite fly. So you go back through all those chains of A became B, became C, became D, and from the point to that point when it was a published RFC. I have decent data around 2003, 2004, when the number of years to do that process seemed to be pretty around 3 to 4 years. These days, they do come out in bursts if this is done by month, but it is somewhere between 8 to 12 years, one way or another, to actually go from the initial draft through to an RFC these days. Next. And I've sort of compressed it up there, done it by RFC number, which is actually a nicer way of doing things, because the RFC number is kind of monotonic, but it doesn't have the work bursts in time. It just says RFC numbers. So from about RFC 6500 onward, that time has been stretching out. The early drafts, and this is directly to your point too, around 3,000 to 3,500 came out within around 2 to 3 years. Relatively straightforward. These days, that is a rarity. Some do, but most of the time, that entire period is somewhere between 4 and currently between 6 and 8 years to actually go through the mill.
Yeah, so this is great to show the average. It would be nice to show the phase, the statistical spread of a Poisson distribution over this time period to see the ones. So anyway, just data processing.
Data processing stats, call in the actuaries.
Yeah, I mean, coming back to the, Colin Perkins, coming back to the comments you were making earlier, I mean, what's instructive is to also look at the number of citations to previous RFCs, the amount of mailing list discussion of each draft, the number of RFC 2119 comments in the drafts and so on. And there is a clear trend of increasing complexity and increasing discussion and increasing difficulty in coping with the backwards compatibility with all the previous things. So yes, the delays are increasing, but I think it's very clear why they're increasing.
You see, I have no value judgment on the fact of why. I'm just flying over the landscape at 30,000 foot going, this is the landscape. Sure. I understand there are reasons, but I'm not trying to actually produce any here in this pack. It was just, these are the numbers. So I appreciate the point. I think it is a lot harder to get an RFC out that actually makes sense. In today's world where you're charting through previous work, you're trying to understand if it reinforces or contradicts it, what you're trying to say in the context of all the work we've done before. That's a lot of time and a lot of work.
It's a lot of work, and I think it's an unsurprising increase as the technology matures, as the network matures, as there's more need for backwards compatibility. it's harder to produce an RFC than when you're starting from scratch with a green field.
Harder equals longer. Before we go there, Susan, let me see if there is a next slide. I've forgotten what I said here. Okay, I gave you answers. So currently around 6 to 8 years. That's about 4 times longer than it was 20 years ago. And as I said before, the success rate of actually getting through this process is around 1 in 5. Is that it? Is there another slide? I promised. Christian Huitma in 2021 actually did a deep dive into a small number of RFCs and picked apart every piece and every step of the process. It's interesting reading because that then does get into the reasons why, which I have not done here, just have not. Oddly enough, the data is there, but you know, life is finite. There are many things to do, and spending my entire time combing through data tracker statistics and seeing state changes is not exactly top on my list. Others might find it entertaining. And I think that's it. Yes, it is. So yes.
Some of us did find this entertaining.
Great. More power to you. And I'll take a step back and you should be up here next time.
We wrote an IMC paper in 2021 that talks about this in great detail.
And I think, you know, this kind of stuff is relevant. While Susan comes to the microphone, I do remember from the very early days, 89, 90, 91, where we prided ourselves that we were fast, lean, efficient, and pragmatic, and the ITU was not, and this is wonderful. But I'm like, once you're in the mainstream of this business, you are the business, then complexity kind of creeps up. And with complexity comes indeed all of these issues about trying to get the message right, as distinct from getting any old message out the door. And I think that's just maturity of what we're doing. But you might have a different view, Susan. I don't know.
The question was, do I find that complexity is causing some of this? Yes, because when you have to wedge in something based on all the stuff we've been doing before, it takes a little idea to see if we're going to break something and cause some meltdowns. Now, not that a working group I'm familiar with would do that. What a concept. So the point is, just to let you know that the stripe I did has, and what I mean by a stripe is 10% of the RFCs. And yes, Jeff, I had nothing better to do with my life than look at that. Thank you very much for that.
I'm glad you do it.
That comment. I had a wonderful time. But one of the reasons your stripe between 2002 and 2006 is a little funky is there's also some weakness in the data at that area because the data tracker was in a transition period. And so you'll find that things are missing if you do a deep dive.
I thought it was my lost radar.
No, it wasn't your lost
well, it
rate.
might well have been.
When I tracked it down, and then when I tried to track down the ISG processes in there, even the notes are a little squirrely. Not going to comment.
You're saying it's not me?
No, it's not you, dear.
Yay!
So the point is, I think the deep dives are useful. I think it's also, again, to Lars, you got to look at where the delays are.
I think the next step is, you know, are we doing the right thing by this? Is the process, et cetera, et cetera. And that level of introspection is not here. This is just a straight up, this is just a pass through the data to see how long it's all taking. And I think we have run out of time? Whatever. I've run out of slides. You've run out of questions. Andrew.
Questions.
So just, sorry, Andrew Campling, for the people remote. Two observations. One, I guess 6 to 8 years, if that's what it is now, we might want to question whether the stuff's still relevant when it comes out the other end of the sausage machine. And complexity notwithstanding, it's not much point producing stuff if it's already obsolete. And maybe picking up on the comment, I think from Colin, if most of the 6 to 8 years is vested with the ISG, maybe we should give some KPIs to the ISG just to inject a bit of speed into the process.
Oh, those are microphone forming, cue forming words here.
Jonathan Hoyland, Cloudflare. I've only been coming to IETF for 5 years, and I want to thank you for giving me hope that my drafts might one day come out. Thank you. That's appreciated.
Thank you. Like I said, I wrote this original blog article out of acute frustration. You know, I was just feeling myself, oh my God, why is this happening to my favorite draft? But anyway.
Colin Perkins, to correct the record, this is not the IESG's fault. This is not the IESG which is the delay here. It does not take 8 years to publish an RFC. The data we have looking at it, it takes 3 or 4 perhaps. And yes, the time is increasing, but it is not the IESG processing which takes the time.
I'm not saying where the process is. I'm saying from the initial 00 through to an RFC.
I understand that.
And we agree that it is around 6 to 8 years, because that's what I see in the data tracker.
The data we see is nearer 3 to 4. So I think there's something wrong with your analysis.
Oh, I'm wrong.
I think
the
so,
IESG
yes.
is always right. Sorry.
No,
yes, you're quite right.
I think you need to listen to what people are saying here. The delays are not the IESG processing time. The delays are the working groups and the discussion in the working groups, and there is considerably more working group discussion and considerably more revisions in the working groups and considerably more cross-references to previous drafts, more normative statements, and that is what's taking the time. We have done this analysis. So please look at the prior work.
Thank you. We done? That was Colin. That was it. Oh, Susan.
I will disagree with my esteemed colleague, Colin, that I think there's a little bit of flux in both in the working group, since I've seen plenty of that, and also in things that happen inside the ISG.
And if we ever had a metric of time to product, it would be different again. I don't think this is an industry that works in a speedy fashion. Thank you.
Thank you, Geoff, and thank you everybody for the very interesting discussion and for joining the session. Bye, everybody.